Now, what if I have 2 points? Let's look at how I can find the equation of the line that passes through the points 1, 4, and 2, 3. And in this instance, I'm going to use point slope form. So the first thing that I'm going to do is calculate the slope. Remember that for slope, I'm interested in the change in y over the change in x, or you may know the formula y2 minus y1 over x2 minus x1. It's really important that I get the right pieces right. So the y is the second coordinate, and I'm going to call this the y coordinate of this first point, y1, and the y coordinate of this second point, y2. And the x's are this first coordinate. It's important that these line up in the order. So I'm going to call this first x coordinate x1 and the second x coordinate x2. If I'm plugging in here, I'll get 3 minus 4 divided by 2 minus 1. When I simplify, this gives me negative 1 over 1, which is just equal to negative 1. So I've established that my slope is equal to negative 1. I'm not done yet. I still want to find the equation of the line. Don't stop here. We need both the point and the slope. So now the question is, can we find a point out of the information that we have? In fact, we have 2 points, don't we? So we actually have 2 options. I'm going to take the point 1, 4. If you wanted to take 2, 3, it wouldn't hurt anything. And so now I'm taking this point 1, 1, 4, and I'm going to take the point and the slope that I have and put this into point slope form. Y minus y1 equals slope times x minus x1. And I wish I had drawn this one clearer. I actually ended up changing my mind about which point to use and then changed it back. But anyway, this point is 1, 4. So this is my x1 and my y1. I'm going to take y minus 4 is equal to negative 1 times x minus 1. From here, I'm going to do the process I did before. So distributing this negative 1 through, I get y minus 4 is equal to negative x plus 1. And then adding 4 to both sides to isolate y gives me y equals negative x plus 5. So here's my final answer. The key is, once I decided to use point slope form, which I decided at the very beginning, the information that I needed was a point, and I actually had 2 points to choose from. And I could pick either one, but I needed to use those 2 points to calculate the slope so that I then had a slope and a point to plug in. Now, can I do this another way? Yes, absolutely I can. I can do it directly with y equals mx plus b. I'm going to screenshot my recording here because I definitely don't want to repeat all of this calculation. The slope is going to be absolutely the same. All that's going to change here is I'm going to go directly into y equals mx plus b using one of the points. So looking at this, you have the same slope information. So you're going to get the same slope calculation. You'll end up with the fact that the slope is equal to negative 1. And trying to use our y equals mx plus b form, we still need a slope and a point. So I figured out that the slope is equal to negative 1. Now I need to figure out, can I plug in a point? And just like before, I have 2 options, which hopefully is not too many, but I'm going to have a 2 for my x and a 3 for my y. And so I have m equals negative 1, x equals 2, y equals 3. And then when I plug this in, I'm going to end up with 3 equals negative 2 plus b. So then if I add 2 to both sides to cancel out and get b by itself, just like before, I end up with 5 is equal to b. And so then I take this 5 equal to b and I put it back in here after I already knew that the slope was negative 1. And so that goes in m. And so I will have y equals negative x plus 5, which is the same answer I got the other way. I'm not going to force you to use slope-intercept versus point slope. It's interesting that you have the 2 different ways, and there's definitely reasons to have both ways. And it's when we do tangent lines later, you'll find that point slope is often easier. Both of these methods work for finding the equation of a line, given the information that we've had so far.